Hello, my name is Bart Brecka. I'm today going to build a spring, a clutch spring in Creo. This clutch spring will have a ground end, and I'll be able to flex the spring into different positions, different sizes. Notice the end is ground. Before I start the spring, I want to show you where in our Advanced Assemblies class the spring is located. Design Engine spent many years putting together training material. So what I'm going to do is place the spring inside of a box like this. The same part number exists 3 different sizes. I'll use a relation driving the pitch with the length of the geometry. Now I'll go ahead and start modeling the spring. One of the things Design Engine's known for is being able to manipulate geometry at a high level. To us, it's not how fast you model something, but how fast you change it 20 times that makes you an expert. All right, so there's the bounding box structure of the spring. I can double click on the bounding box and change dynamically that length. I'll go ahead now and build the helical sweep. So in the helical sweep, I'll use edge on the geometry itself, this project tool inside a sketcher. Notice the start point is at the top. If you left click at the bottom, right hold down, you could move the start point. In this case, I don't think it really matters, but in the end, I'm going to want to grind the top of the bottom, and I'll use the bounding box to do that. Notice the user interface is red right in this area. That means it's missing some information. I've got left to do the axis of revolution, and I need to sketch the section. Notice the section's grayed out. So the next thing I'll do is offer the center what I'm spinning about as the part of the bounding box. You could also grab the Y, part of the coordinate system. Now I'm going to take it back to the sketch. This is where I'm going to put in the cross section for the spring. And I can dynamically change the cross section. Little click, and there's my spring. Now if I change the spring height, it's changing the number of coils. A spring typically keeps the same number of coils. So I need to be able to, this is where I'm going to tie in that relation. So what I'm going to do is I'm going to build my relation with respect to the length of the part. So I'm going to go ahead and make the cross section first. I'm sorry, the pitch is what I'm going to drive. So that's the first part of my relation. And I'm going to make the pitch with respect to the length of the part. And I'm just going to multiply that by 0.1, 0.2, and then when I hit Control G, you can see that it took the value. Now when I drag the spring up and down, it's keeping the same number of coils. Okay, now this is where I need to grind the ends. So I'm going to go ahead and do that as a sketch. But this sketch is going to locate itself with respect to the box itself. So I'm just going to go ahead and sketch the shape of the cut and use coincident to constrain it to the top. And I'm going to go ahead and extrude that as a cut. I'm going to go ahead and make it right hold down on this dot and make it go through all both sides. And then let's test the geometry to see if the grind stays located. Now, that's not something you could do if you're counter and you're counting features. This extra feature allowed me the flexibility to derive the grind cut that wouldn't update like that. And many of us prefer to count features and define complexity in terms of how many features there are. Design engine, we realize that complexity is in terms of how long it takes to regenerate. I'm going to go ahead and just add that grind at the bottom as well. Right hold down through all those sides. Cut. Now I'm also going to go to insert now before these features exist, and I'm going to play a little bit with color. I'm going to go ahead and select all the outer surfaces of this geometry, and I'm going to color the spring this sort of dark color. And when I zoom out, you can actually see the grinding geometry. That's nice for a visual, so we can see what machining operations might occur.